this is the future. EV is the future. Thank you, sir. So with this, we move on to our next speaker, Padma Shri Professor Anil K. Gupta. So Professor Gupta is a visiting faculty at the Center for Management in Agriculture, IIM Ahmedabad, and also at IIT Bombay. So with this very short introduction, I first thank all the panelists for giving more time to our viewers. So Gupta sir, over to you.
Thank you. Let me share my screen and yes. Good afternoon. I'm very happy to be here with you all because Dr. Kalam was not only a great friend of Honeybee Network, but a great promoter and a patron of the inclusive innovations from grassroots level. No matter where he had occasion to talk about it, he would always refer to the innovations by the common people. So much so that we named the Children Creativity Innovation Award after him, and I will talk about it a little later. The point that I'm trying to make today is slightly different from what the previous two speakers have said, because they talked about very well about the options that are available in the electric vehicles or electricity use. Ashok mentioned very categorically about the choices that we have across the spectrum of renewable and non-renewable energy. And Mahesh also mentioned about the options for three-wheel vehicle. What I will do is to bring some insights from the grassroots level. So let's look at this simple way of harnessing energy in a village of Meghalaya, Cherrapunji. What is this lady trying to do in this house where we walked there during our Shodhyatra in Meghalaya? This is the place where cooking is going on. There's a shelf here to cure the wood which is used for trolleys in that place for transportation. The wood becomes strong when it is heated. Now, if we go further, the temperature has gone down slightly. As the smoke goes up, the temperature is lost. And what we are witnessing here is a beautiful functional use of energy loss as it takes place. In other words, energy loss is not really loss, it is becoming more functional for a particular purpose. That to me is the crux of the matter, which we probably have not paid enough attention to. So here you are drying the wood for fuel purpose. As you know, Cherrapunji receives the maximum rainfall in the world. Fuel wood is moist or wet, needs to be dried. And here meat and cheese can be dried up, and on the top there is a bag of seeds which is fumigated with the smoke, which doesn't have much temperature but has a little bit of carbon dioxide and other gases, which will then disinfect it and prevent insects from eating the seed. Look at this multi-level, multi-shelf basis of energy harvest. So how do we discover this? We discover it through Shodhyatras. I have walked in every single state, from Andamans to Gorej Valley in Kashmir. 45 walks that we have had in different parts, in different agroclimatic conditions. And obviously, we have come across innovations which have renewability, but not only renewability. There could also be non-renewable energy, but used very efficiently. There could also be one of the most important determination of the grassroots innovation, of course, affordability, accessibility, availability, and local repairability. Now let's look at some of the simple reasons, some of the basic reasons. Why do these innovations emerge? They emerge because very obvious to many of you, that there are people who are materially in an energy constrained environment. They don't have access to other things. They also have a desire to do something different, something sustainable, something frugal. And frugal not just for the consumer, but frugal also for the environment. And they want to collaborate. Not all of them, many of them, to get feedback from the users. They have compulsion of survival, of course. When there is nothing else, they have to survive with whatever they can have access to. And of course, there is a circular economy. They repurpose the old parts. They repurpose the available resources and the affordability. Now let us look at some of the key heuristics, just as an example of how can we learn from the innovators if we want to develop energy policy and energy technologies and products and services. So the first one, which is very intriguing but very true, You either preheat the fuel or preheat the air, or both, and the combustion efficiency of the fuel goes up. Now, I'm surprised. We have tried with auto industry, and I'm happy that Mahesh Babu is here. I would very much wish to use this simple concept. So what did one Mr. Mandal did in Guwahati? He took the hot air, he took a pipe around the exhaust. That was then put into the carburetor because he got hot air and mixed it with the fuel. That improved the efficiency of the fuel combustion. A very, very potent idea. We will see many stoves where grassroots innovators have used this. So there are some very beautiful heuristics underlying the innovations for energy from which we can learn, optimize them, elaborate them, amplify them, depends how the scientists can use it. Second, I gave you an example of the kitchen, the hut kitchen in the heat. How can heat gradient be used for functional purposes to improve energy efficiency? We often, what do we do in a geyser? We raise the temp, we make the water hot at 60 degrees, and then we mix the cold water in our bathroom and use it. Very inefficient use of geyser. What do we need? We need hardly 40 degrees. So either you set it at 40 degrees, which is the best way of using the geyser. Secondly, what we do, we take the water from the bottom. We know that current will make it such that the heat will go, the hot water will go up, but we take the water from below. So if there's a floating wall which will divide, which will give you the water from the upper layer of the geyser, you will get hot water at much less cost. You don't have to boil, you don't have to heat, let's say 20 liter, 30 liter, 40 liter of a geyser capacity to get hot water. I mean, there are basic design defects. There are basic design defects in the way we are using energy. The last example of heuristic, there are many more, but I have just picked up a few, is that not all activities that we do in our production systems, in manufacturing, in agriculture particularly, need high speed. They don't need faster time, and they don't need high output. Now, this may look counterintuitive, but in irrigation, you have slow irrigation, small irrigation, and even irregular flow, and it is more efficient. You give more water, more nutrients are lost. Less aeration takes place. More pest attack takes place. More water, more pest attack. More water, more leaching. Faster water, erosion. So now look at this. There are principles of efficient use of energy which are also economical, if only we will pay attention to them. So let's look at how two innovators from Assam, Mehtar Hussain and Mushtaq Ahmed, discovered this principle. So they had a windmill which they used for pumping water from a hand pump. And they asked two questions. And these are heuristic questions. One, does it matter whether water comes in a spurt or smoothly? Because the hand pump has a single valve. So when you pump the water, it comes in, come and go, I mean, because of the single valve. Second, does it matter whether paddy field is irrigated in 4 hours or 40 hours? Look at the beauty of the question that you ask, because design will follow from the question. Ideally speaking, there's no rush to irrigate the field. Why should I use a high horsepower engine and then finish with the task in 4 hours? I can as well irrigate in 40 hours. Slowly and slowly. Slow irrigation, as I already mentioned, is more functionally efficient. It leads to less leaching of nutrients. It causes less problem with aeration and can be used by the plant. Plant needs moisture, not water. And yet we flood irrigate. All over the country, we flood irrigate. Because engine is available. I can finish my work in 5 hours, 10 horsepower, 12 horsepower, 15 horsepower engine I will use. Very inefficient way of irrigating crops. Let's look at some other examples of this. So this is a Saifuddin stove from Maharashtra. What did he do? He took the pipe of fuel around the flame. So fuel got heated up. When fuel got heated up, thermal efficiency went up to 52%. The best stove that Indian Institute of Petroleum has so far evaluated is about 60%. This fellow achieved 52%, which is almost like 90% efficiency of the best stove through his grassroots innovation at a cost less than 1,000 rupees. Why can't we change the standards? And I'm sure Ashok will think about this, that if there are some efficient solutions available at low cost, we should change Bureau of Indian Standards for designing stoves, kerosene stove. It is more efficient than the Indian oil stove. Look at the next one. This is from Pilibhit, Niranjan Prasad, same thing. He also uses 25% less kerosene, again, because it is heating. The fuel pipe is coiling around the flame, and as you ignite, it gets heated up. Jayaprakash has used a wood stove, which is much more efficient. This is a rice husk stove, which can be used even on a boat. So when there is a flood in Bihar, you can use this, very efficient, gives a blue flame. So this is the firewood banquet by Tamil Nadu. Similarly, now this is a very interesting idea that Jyoti gave from Udupi. She made a water jacket around the stove. Now the heat which was going waste, she harnessed it. Now if you put rice or dal in hot water, it needs less time to cook. Your energy is saved. Simple. Just for 15 minutes or 20 minutes, put it in the hot water and then cook it. It will take half the time, so fuel is saved. Why don't we advertise this? Why don't we publicize these practices? That's simple ideas, for whatever good reason, they are prudent, they are conscious about this. So let's look at now the next part, mini hydro turbine. Ratnakar is also called Turbo Ratnakar. Now, the beauty is that the water velocity in the stream is variable, as Ashok had mentioned earlier, which is a very, is a common problem, is a very constant problem in all the renewable energy, that the speed is not constant. Flow rate is also not constant, obviously. And therefore, the energy that you generate will not be of uniform quality, but you can, of course, through the different alternatives, make it possible to use it so that your device doesn't get affected. He has made from 1 kilowatt, 3 kilowatt, even up to 40 kilowatt. So for coffee gardens in this area, it is a Virapans area. People have, in the remote areas, they use this device and can make their energy renewable, and it works very well. This is another Nippon call it a zero head turbine. When you have a river, you don't have a head, you can use this turbine to generate energy by the flow. There are many such hydrants available in Uttarakhand and many other places, but these are done by the people themselves and they are using very low cost technologies. This is a very interesting idea by Imli Toshi in Nagaland. What did he do? He had a bamboo lathe machine. So he used to get a lot of powder of bamboo, mixed with a resin and made a composite. And he made the turbine, the blades of the turbine with the bamboo composite as it is shown in the photograph, which means that the energy required to move these blades was much less than if they were made of metal. Very interesting use of renewable resource for generating power, even with less flow rate and with less cost. This is again the same concept, multi-utility fuel efficient. This is a very interesting thing from Manipur. You are using a stove to dry. Now you need different temperatures for drying different things. So you decide at what distance, which shelf should you put what material to dry. See, in our mind, we always believe in constant supplies, constant supply of power, constant supply of heat, uniform supply of heat, and the whole mindset leads to very costly outputs, very costly designs. But actually speaking, not everything needs to dry at the same temperature. Not everything needs to dry quickly. In fact, slow drying makes it more tasteful, less loss of nutrient. So we must recognize that there are efficiencies in slowness. There are efficiencies in the gradient of temperature rather than the constant temperature. And these gradients, which happen because we can't maintain the uniformity, can be harnessed profitably. So this is the triangle that we are trying to make it happen. Gyan, which was set up in 97, Shashti, which was set up in 93. Innovation, investment, and enterprise. We have innovations. We need investments, and we need entrepreneurs. Ashok knows it well because we have been discussing this for 30 years now, that not every innovator can become a good entrepreneur. Innovator can't make two things alike. Entrepreneur has to make batch by batch constant production. It is here, Mahesh, that we need to have a partnership between corporations and communities. Corporations and communities can join hand. If nothing else, the corporate designers and engineers would learn about frugal ways of solving problem. You would throw away the solution, doesn't matter. But the mindset, the heuristic, the way of thinking which generated a frugal solution needs to be learned, because our engineers are trained in highly resource abundant environment. And surely when you live in a resource abundant environment, how will your mind think of saving on materials and other possibilities of saving energy in that regard? So I would say it is useful. It is useful to have this partnership, not only to help innovators, but to help ourselves. We can learn many heuristics. Now, I would like to mention in the end, a few examples of democratization of innovation and creativity. We are a great believer in sharing knowledge. So if you go to gyan.org/patent.php, Ashok, this is one of the recent databases. Two students, Devika and Zagam, who were in my class at IMA some years ago, made this 0.8 million abundant US patents. 0.8 million abundant US patents are free to use by scholars, entrepreneurs, students, and startups. And they include a lot of energy technologies. Now, since they have been abundant, we can refer to them, we can use them, and draw upon in our designs with, of course, due attribution. Similarly, Techpedia, you know, Techpedia has more than 200,000 engineering projects now, information of 200,000 projects by 500,000 students. These are like half-baked bricks. We want to build a beautiful mansion. Some of these bricks can be put together. Some of these bricks can be baked properly, and we will have new materials, new ideas, new insights that can be used. This is the QR code of our Honeybee databases for farmers, for common properties. Anybody can access it, just scan it, and it is yours. No password required, no user ID required, no reciprocity required. There's no condition in it. Unless you share your knowledge, I will not share. No, there's no condition. You share or not, I'm sharing. Honeybee Network is sharing. And this is the spirit. That's why Dr. Kalam was always so appreciative of what we were doing, because he saw a purpose, a purity of public purpose that we were trying to achieve. So we are now organizing two competitions. I want to use this occasion to publicize. One is Dr. APJ Abdul Kalam Ignited Mind Children Creativity and Innovation National Competition. NIF has stopped this competition. They have now started, they continued Manak. So therefore we decided to take over from this year. In this competition, children can send ideas directly, unlike the Manak, where they have to send, their ideas are selected by the principal or the teacher, and they only can nominate 2 ideas from each school. Here we have no condition. You can send as many ideas as you want directly, no bureaucracy, no hurdle, no restriction. ignitedmind@honeybee.org. That's the address. And second is HBN Kriya, Creativity and Inclusive Innovation Award. This is an award where anybody can participate. HBN Kriya, CRIIA@honeybee.org. Anybody can participate, professors, teachers. You know, one of the great problems in our country is that many times in science exhibition, you have seen children come out with models which are made by their teacher or their parents. And they come to the exhibition and say, this is my model. This is not their model. The whole ethical foundation of the society is ruptured when we ask children to claim something as their own when it is not. And I feel very sorry about it, that year after year, I see parents and teachers trying to help their children thinkingly, but they are actually stifling their creativity. So if we really want to promote creativity and innovation, we will have to let children be, and therefore let them share their ideas, but their parents and their teachers can give to NP and Kriya awards. So they don't have to give their ideas in the name of the children. This is Sashti, which is the backstopping institution for Honeybee, both Sashti and Gyan. And this is the belief that we have. So let me close by saying creativity counts, knowledge matters, innovations transform, and incentives inspire, but not just material incentives, also non-material incentives, and not just individual incentives, but also the collective incentives. This is the thought that I wanted to share with you. I hope that it provides a different perspective, but in the same genre, that how do we learn from people and cross-fertilize the ideas in formal and informal sector. Thank you.
Thank you very much, Professor. It was definitely from a altogether different perspective. Starting from everyday use. I mean, it was so heartening to see so many real day-to-day solutions. That's been found out. Especially, the functional efficiency that you mentioned and the paddy field example. Absolutely, the plants need moisture and not water. So we just pump and then assuming that there's a lot of efficiency, but there isn't. So that was absolutely a great example. And then the frugal way of solving problems is what you mentioned, which is basically we say in India jugad. So more or less. So the example what we saw in this pandemic period was basically people started making their own face masks, shields, and ventilators. They started to find solutions to kind of daily problems. And at the end, which you really mentioned, inspiring students to be their own innovations and not teachers or students. I mean, our parents support them, and so that the ethical way of innovation. Absolutely, it was great listening to you, and I'm sure all of our participants would have also enjoyed thoroughly with all this live examples and possibilities that exist within our nation. Thank you so much, sir. So